So hello everyone, welcome to this new video. So in the previous video I had started with module 2, that is vector space and linear transformation, where we have discussed some concepts related to vector space and how it is a subspace of the vector space and how the conditions are not in the subspace of vector space. Everything we have discussed in that video along with the few problems. So in this video we are going to discuss with linear combination. Okay, what is linear combination? Let us see it now. Let V be a vector space over a field F and let V1, V2, V3 up to Vn belong to this vector space V. Okay, now any vector of the form a1 v1 plus a2 v2 plus a3 v3 up to an vn, where a1 a2 an are some constant values in the vector space V, where ai, that is a, all the values of a a1 a2 a3 up to an comes under ai, belongs to F, then it is called the linear combination of the vector space V. Okay, so linear combination means if we have a vector space where v1 v1 values are from v1, v values are from v1, v2, v3 up to vn, it belongs to V, then its coefficients or the constants from a1 to an along with this vn, these all belong to the belongs to the set of F vector. So then we can say that it is a linear combination of this vector space. Okay, next let us see about linear dependence. Let V be a vector space over the field F. The vectors v1, v2 up to vn are said to be linearly dependent over F if the scalars, that is a1, a2 up to an, belong to F and their linear combination is equal to 0. Okay, if you do its linear combination, that is by adding a1 v1 plus a2 v2 up to an vn, if we get our answer as 0, then we can say that it is linearly dependent. Okay, but if ai is not equal to 0, that is for all the values of ai not equal to 0 where I belong to n, the values of a1, a2 and an, it should not be equal to 0, it should be a set of natural number itself. Okay, it should not be equal to 0, then only the linear dependent condition satisfies. Okay, if we get this part, if we do the linear combination part and if we get our answer as 0, then we can say that it is linearly dependent. Similarly, for linear independence, let V be the vector space over a field F. The vectors v1, v2 up to vn are said to be linearly independent over F if scalars a1, a2 up to an belong to F, so that a1 v1 plus a2 v2 up to an vn is equal to 0. But here in this case ai should be equal to 0, that is these values should be equal to 0, then only we can say that it is linearly independent. Okay, if ai equal to 0, then it is independent. Okay, if any of the values of a1, a2 up to an is equal to 0 at some stage of time, then we can say that it is linearly independent. Okay, where I here belongs to the set of natural number. Let us next discuss about linear span. Okay, let S be a subset of the vector space V over the field F. The set of all linear combinations of vectors in S is called a linear span of S and it is denoted by L of S. Okay, so this is the denotation of a linear span. If S is equal to phi, phi is a null set, then we can say that L of S is equal to 0. Okay, so this is about linear span. Next, basis or base of vector space V. Okay, let V be a vector space over the field F. The set of vectors v1, v2 up to vn is called as the basis of V. If how it is called as the basis of V, let us see. If the values of v1, v2 up to vn are linearly independent and as well as v1, v2 up to vn are the linear span of V, i.e. each vector can be uniquely expressed as the linear combination of v1 up to vn. Okay, so in this way the basis or base of vector space V is satisfied. Firstly, the values of v1 up to vn should be linearly independent and it should be under the span of V. Okay, then only we can say that it is called as the basis vector. Okay, next, dimension of vector space. Number of elements in a basis of vector space V is called as the dimension of V and it is denoted by dim of V. Okay, if V contains a basis with n elements, then dim of V is equal to n. Okay, so this is called as the dimension of vector space and it is represented as dim. Now note one thing. The vector space 0 is defined to have dimension 0. Since empty set phi is independent and generates 0, so we can say that dimension of 0 is number of elements in phi, that is 0. When a vector space is not of finite dimension, it is said to be of infinite dimension. Okay, when it is not of finite means it is not has a particular set of values. Okay, so these two note you should be doing. So these are the important definitions of linearly independent, linear dependent conditions, linear span, basis function, dimension of vector space, and much things. So whatever we have discussed till now, that you would be understanding in detail while we solve the problems. Okay, so we are going to solve few problems now to make you clear about these concepts. So this is the first problem under linear combination. Write the vector v, that is the v is given as 1, 3, 9 as the linear combination of vectors u1, u2 and u3. Okay, where u1 is given as 2, 1, 3, u2 is 1, -1, 1 and u3 is 3, 1, 5. Okay, you should be representing this vector v as the linear combination of u1, u2, u3. Okay, let us see how to represent it. First, initially for all the linear combination condition, we know that v is equal to anything in any some value into the given conditions, that is u1, u2, u3. So we can say that let us take x into u1 plus y into u2 plus z into u3 initially. Okay, let v be equal to x u1 plus y u2 plus z u3. Okay, take it as equation 1. So in order to represent it as a linear combination, you take it, that is the value of v is 1, 3, 9, x into u1 2, 1, 3 plus y into 1, -1, 1 plus z into 3, 1, 5. Okay, in this way we are representing it as a linear combination. Now our task is to find the values of x, y, z. Okay, in order to represent in this form, we should be having the values of x, y, z. Okay, then only we can represent it as a linear combination of these vectors. Okay, so how to find the values of x, y, z? Now what I am doing is 2, 1, 3, I am writing it in the form of equation, that is 2x plus y, that is coefficients, I am writing it, plus 3z, that is 2 is represented as 2x, 1 is represented as 1y and 3 is represented as 3z, that is equal to the first number, that is 1. Similarly, here this term 1 minus 1 I am representing as x minus y plus z equal to 3. Similarly, 3x plus y plus 5z equal to 9. Okay, so this is in this way I have written the equations considering these three parts. Now consider ax is equal to b. Okay, this you might be knowing it, you have solved it many times, where A matrix are the coefficients of all these things, that is x, y, z, 2, 1, 3, 1, -1, 1, 3, 1, 5. Okay, and x matrix is all the variables x, y, z, and B matrix is all the outer values 1, 3, 9. Okay, if you consider this ax is equal to b form, now you might be knowing the term augmented matrix a dot b. Okay, so this you might be having in the first semester. That concept you are going to apply it here now. That is equal to 2, 1, 3, 1, -1, 1, 3, 1, 5 augmented with 1, 3, 9. Okay, just together I have represented it like this. Now what I am doing is I am finding the rank of this matrix. Okay, how to find the rank of its matrix? You should be making the first column elements, first element, leaving that the second two elements you should be making it equal to 0. Okay, how you could be tending that values to 0? First what I am making is I am interchanging first row and second row. Okay, because it would be easy for me to solve them. After interchanging, that is, we will be getting first row as 1, minus 1, 1, 2, 1, 3, 3, 1, 5. Okay. Now, in order to make the first two elements equal to 0, this you need to make it equal to 0, right? So what condition we should be applying? R2, that is the second row, should be equal to R2 minus 2R1. Okay, I am using the first row and making this element equal to 0. That is R2, that is 2 minus 2 times R1. Okay, if you want to make it 0, if you do 2 minus 1, you would be getting 1. If you do 2 minus of 2 into 1, that is 2 times R1, then we would be getting this term as 0. Okay, this, well, if you make this like this, then you would be getting this term as 0. Similarly, if you want to make this term equal to 0 using the first row R1, that is R3, it would be changed to R3, that is 3 minus 3 times R1, right? Because if you multiply 3 into 1 only, then only we would be getting 3 minus 3 as 0. Okay, so make this change and rewrite the matrix again. Let us see what we would be getting now. First row, keep it as it is. 1, minus 1, 1 and 3. So now here first element is 0. Then here apply the same condition again. R2 minus 2R1, that is 1 minus of 2 into minus 1, that is minus 2 minus 1 is plus 2. So 1 plus 2 we will be getting 3. Similarly here 3 minus 2 times R1, that is minus 2 into 1, that is 2. So 3 minus 2 is equal to 1. Similarly 1 minus 2 times 3. So 1 minus 2 3s are 6. So 1 minus 6 is equal to minus 5. So here also R3 minus 3R1. So 1 minus this term 3 times of minus 1. So minus 3 into minus 1 is plus 3. So 1 plus 3 is equal to 4. So 5 minus 3 times 1, that is 5 minus 3 is equal to 2. Similarly, last term 9 minus 3 times of first element 3. So 9 minus 3 into 3 is 9. So 9 minus 9 is equal to 0. Okay. So like this the matrix has been changed now. Now our goal is to make this element equal to 0, right? According to the rank condition. So we need to be changing the third row R3 in order to make this equal to 0. How we could be making now? This you should be making using the second row. If you use second row only, then you could be making this element equal to 0. Okay. Now using second row, how we can make this element equal to 0? If you change this as, since we have the values 4 and 3, okay, the nearest values, so we could be writing directly as 3R3 minus 4R2. Okay. So using the second row, I have made the third row element this equal to 0. Why? Because see here, if this is R3 value, so 3 into 4 minus 4 into 3, that is 3 into 4s are 12 minus 4 3s are 12. So 12 minus 12 would be equal to 0, right? So that's why I'm changing R3 from 3R3 minus 4R2. Okay. Now the matrix would be again get changed, that is first row as it is, second row after the change you write it as it is, 0 3 1 minus 5, this term 0, then this would be now 0, and here it would be changed to 2 and 20 after the given applied condition. Okay. Now therefore rank of matrix A equal to rank of matrix A augmented with B. So we can say that those are equal to the number of unknowns also. That is, these are the number of unknowns 3, right? So rank of matrix is 3. Also the rank of augmented matrix is also 3, and number of unknowns are also 3. So if this is the condition, we know that it consists in first semester you have studied, right? It consists of a unique solution, right? So it has a unique solution. that is x, y, z has some separate set of values so that it could be represented as a linear combination. So if only if it has a unique solution in these kind of problems, then only we could be representing it as a linear combination. But if it doesn't have any unique solution, because if rank of A is not equal to the augmented matrix rank of A of B, then we can say that it does not consist a unique solution, then it cannot be represented as a linear combination. Okay, so now it consists of a unique solution. Then next what you should be doing, now consider these three terms and write it in terms of x, y, z, that is x minus y plus z equal to 3. Then this is 0, so with this term you write it as 3y plus z equal to minus 5, and here 2z equal to 20. Okay, so now using these three equations, solve for the values of x, y, z. Okay, first this is the easiest part, that is 2z equal to 20. We can do it as z is equal to 20 by 2, or we can write z equal to 10. Okay, using the third equation I've solved for z. Similarly, you can solve this second equation, 3y plus z equal to minus 5, putting the value of z equal to 10. That is 3y plus z is 10 now equal to minus 5. So 3y would be equal to minus 10 minus 5. This 10 I brought it to other side, this would be minus 10. 3y is equal to minus 10 minus 5 is minus 15. Y is equal to minus 15 by 3, that is minus 5. So z value, also y value we have got. Now if you put this z value and y value in equation 1, that is x plus y, x minus y plus z equal to 3. So x minus of minus 5, that is plus 5 plus 10 equal to 3, that is x plus 5 plus 10 is 15 equal to 3. So x is equal to 3 minus 15. So x is equal to 3 minus 15 is minus 12. Okay, like this we have solved for x, y and z separately. Now what we could be doing is, therefore initially we have written, right, v is equal to x into u1, y into u2, z into u3, right? So that only I'm writing it again. So what is the v here? According to the question, 1, 3, 9 is equal to x value is minus 12 into u1 is 2, 1, 3. Then y value is minus 5. u2 is 1, minus 1, 1. And z is plus 10. u3 is 3, 1, 5. Okay. In this way, we can be representing it as a linear combination. Okay. So hope it is clear. Like this, you should be solving this problem. So note it down. So similarly, we have one more problem. Let us solve that and see whether it could be represented as a linear combination or not. Okay. Similar problem with some different values. For that, for these kind of problems, you should be knowing the concept of augmented matrix, rank, and when we have three set of conditions here for unique solution, no solution, as well as infinitely many solutions, right? Yeah. So here, according to this, if rank of A and rank of A augmented matrix and number of unknowns are equal, then it consists of a unique solution. But in order to represent it as a linear combination, it should be of a unique solution. Okay. Similar problem is there. Let us solve that as well. So this is the next problem. Write vector v 4, 2, 1 as linear combination of the vectors u1, that is 1, 3, minus 1, sorry 1, minus 3, 1, u2 is 0, 1, 2, and u3 is 5, 1, 37. Okay. So let us see how we could be writing this as a linear combination. Similarly, how we have solved previous problem, in the same way we are going to solve this as well. Let v is equal to xu1 plus yu2 plus zu3. Okay. That is v is 4, 2, 1, x into u1 is 1, minus 3, 1, plus y into u2 is 0, 1, 2, plus z into u3 is 5, 1, 37. Okay. So in this way it is represented. Next, Again the same thing in terms of equation, try to write it, that is first value is x, then the y value we don't have any term, so that's why it is 0y, and here we have 5z, okay, that is equal to 4. Next is minus 3x plus y plus z is equal to 2. Next we have x plus 2y plus 37z is equal to 1. Okay, like this we have written 3 set of equation. Now again let Ax equal to b. So A matrix is all the coefficients, that is 1, y we don't have, so it is 0, 5, then minus 3, 1, 1, 1, 2, 37. Okay, x is x, y is z, and B matrix is equal to 4, 2, 1. Okay, now augmented matrix. That is equal to 1, 0, 5 is to 4, minus 3, 1, 1, 2, 1, 2, 37 and 1. Okay, now we should be finding the rank, right? Rank, how to find? First two column elements you should be making it 0 except the first element. Okay, whenever you find the rank, right, okay, just keep in mind that in the first row, first element should be always be equal to 1, so that it could be easy for you to solve. Okay, yeah, so using first row, you should be making the first column, second and third element equal to 0, right? So how to make it? So second row, that is R2, we should be changing from R2, this time not minus, because we already have here minus 3, so that's why make it plus 3R1. Okay, if you make plus 3R1, what you would be getting? Minus 3 plus 3 times of 1. Okay, that is equal to minus 3 plus 3. Then we would be getting this term as 0. Okay, similarly R3 is equal to, simply because it is 1 here also, so we could be making R3 minus R1 directly. Okay, yeah, so these are the changes. So according to the changes, write the augmented matrix once again. First row as it is 1, 0, 5, 4. Next is 0. And this term here R2 plus 3R1, right? So 1 plus 3 times of 0, that is again 1 itself. Then again this term, that is R2 is 1 plus 3 times of 5, that is 15. So 1 plus 15 is 16. So again 1 plus 3 times of 4, that is 12. So 1 plus 12 is 13. So this is 2, right? 2 plus 12 is 14. Then next term, that is R3 minus R1. 1 minus 1 is 0. Then 2 minus 0 is 2. 37 minus 5 is 32. 1 minus 4 is minus 3. Okay. So this is the new matrix now. Now for this, now this element should be making 0 using the second row R2, right? So R3, how you could be making this 0? That is, you could be making by second row by using this element, that is R3, that is 2 minus, if you multiply 1 with 2, so we would be getting this as 2. Okay, our goal is to make this term equal to 2. Okay, so we could be making 2 times of R2. Okay, so we would be getting this term equal to 0. So again, rewrite the matrix. Now first as it is 1, 0, 5, 4, and second row also as it is 0, 1, 16, 14, third row 0, here also 0. Now R3 minus 2R2, 36 minus 2 times of 16, that is again 32. So yeah, 32 minus 32, you will be getting 0 again. Here also minus 3 minus of 2 times 14, that is 28. So minus 3 minus 28 is minus 31. Okay, so this is our new augmented matrix. So here if you observe, the rank of A, that is all the rows you should be considering except the non-zero, right? So here we have all the row of 0, so this is not being considered. So rank of A is 2 now. Also rank of augmented matrix A is to B, that is equal to 3, all the non-zero. So here we can simply conclude that rank of A is not equal to rank of augmented matrix, right? Hence we can say that it is inconsistent and it consists of no solutions, right? If rank of A is not equal to rank of augmented matrix, then we have no solutions, and simply we can write that it cannot be represented as a linear combination. Since we don't have any solution since we don't have any values of x, y, z, so this is invalid. So this cannot be represented as a linear combination simply. Okay, whenever we get rank of A and rank of augmented matrix is not equal, then it is directly we can write that no solutions, then it cannot be represented as a linear combination. Okay, so like this the problems are solved related to linear combinations. So please go through it. So we have one more problem. Let us see that problem and wind this session. So this is one more type of question where here they have not given any u1, u2, u3 values. Instead of that they have given matrices. Okay, so matrices, in order to represent it in linear combination, it is very easy. Okay, the problem is very easy. Let us solve it quickly. Nothing much to do. First, this matrix you should be representing in terms of B, C and D. Okay, so we could be writing let A is equal to, now let us consider A1. Last time what we have considered X, Y, Z, right? So this time for matrices you consider mostly A1, A2, A3. Okay, A1 into B plus A2 into C plus A3 into D. Okay, this is the equation where A1, A2, A3 belongs to R. Okay, now that is A matrix is 3 minus 1, 1 minus 2. That is equal to A1 times B, that is 1, 1, 0 minus 1, plus A2 times C, that is 1, 1 minus 1, 0, plus A3 times D, that is 1 minus 1, 0, 0, right? So now multiply A1 here, so we will be getting A1, 0 minus A1, multiply A2 here, A2 minus A2, 0, multiply A3 minus A3, 0, 0, right? Now 3 minus 1, 1 minus 2 is equal to, add these three matrices. First element is A1 plus A2 plus A3. Next we have A1 plus A2 minus A3. Next we have 0 minus A2 and 0, so it is minus A2, and here it is minus A1. Okay, our goal is to find the values of A1, A2, A3 here. Okay, in order to represent it as a linear combination, we need to be having the values of A1, A2, A3, right? So now using these equations we could easily find the values of A1, A2, A3. Okay, so if you observe here, directly we got our two values easily, that is A1 as well as A2. See here, here we have minus A2 equal to 1, right? Also we have minus A1 equal to minus A2. So if minus A2 equal to 1, so A2 would be equal to minus 1, and minus minus goes and A1 would be equal to 2. So now here we have one more equation here, that is A1 plus A2 plus A3 equal to 3, right? In this substitute the values of A1 and A2 and find the value of A3. That is A1 is 2, A2 is minus 1 plus A3 equal to 3. So 2 minus 1 is 1 plus A3 equal to 3. A3 equal to 3 minus 1, so A3 would be equal to 2. So like this we have found the values of A1, A2 and A3. Okay, now represent this in the form of A is equal to A1B plus A2C plus A3D, right? So A would be equal to, A1 is now 2B, A2 is minus 1, so minus C, and A3 is 2D. So it would be represented like this. The A matrix is 3 minus 1, 1 minus 2 is equal to 2 times B, right? 2 into B is 1 1 0 minus 1 minus 1 into C, that is 1 1 minus 1 0 plus 2 into D, that is 1 minus 1 0 0. Okay, in this way this is represented as a linear combination. Okay, the required linear combination of A. So hope it is clear. To solve matrix and all, it is very easy. Matrix solving for linear combination. So please try to understand these problems and try to do it. Okay, very important ones. So that's all for this video, guys. Thank you.